Earthquakes. Among the loads that are affecting a material, there are natural loads, and one of them, and one of the most dangerous, are the earthquakes. Earthquakes is the vibration of the earth that is produced by the rapid release of energy. We need to understand that the center of our earth is almost liquid, and there is a lot of energy there that need to be released. Well, that energy is very strong, and we may not realize, because how deep is the location, what is going on inside of the center of the earth. But that energy will travel to the surface of the earth, and it will create some kind of cracks that are present there, and those cracks are around the areas that are called faults. Well, those faults that are cracks in the surface of the earth are the places where that particular energy can be released. And we will find in that area some stress and strain. Well, when the rock breaks, it will release that energy, it will form like a seismic wave. It's something similar like you have the surface of a flat area in a lake and you just throw a rock. Well, that will produce some disturbance and the rock will start producing some wave in the water. The same will happen when the earthquake appears. Well, that energy will radiate, similar to a rock in the water, when you pull a rock in the water, and it will radiate from the place where that happens. In the case of an earthquake, it's inside of the earth. Well, the focus is the place inside of the earth where that break, where that rocks will break because of that energy that is released. The focus is also called epicenter of the earthquake. The epicenter, for the contrary, is the projection of that focus into the surface of the earth. Well, it's the point in the surface that is directly above the point where the earthquake focus is located and where the earthquake originates. Earthquakes will add in structure similar to what loads produce in the structure. Well, they will cause some kind of stress and strain. Stress and strain, also tension, will be expected to build up in the areas around the boundaries of the plates. Well, the earthquake is happening down, and that earthquake will travel to the surface of the earth, and in the place where you have those kind of cracks in the plates, then that will happen. That will produce some kind of strong energy and will affect the rocks that are in the area. The rock can behave of different ways. One is an elastic type of rocks where when the stress is removed, the material will return to the original condition. Also a plastic one, well, the deformation will be permanent. And finally, a rupture, well, the rock will break. Well, we can look here that the asphalt of this particular street was breaking pieces because the earthquake produced fractures in the material. Well, let's look what is going on. Imagine that this is the particular area section of the surface of the earth, and we will see that there we have some kind of shear stress, tensile forces, compressive stress that will be affecting the element. Compression will be to push together stuff. Tension is like an extension to pull them in different directions, and the shear will transform the stress parallel to the surface. Let's look how that happens. How is stress and strain along the faults? For example, an extensional fault is when we have the surface of the earth that is divided in two parts, in this case, like diagonally, and they separate. Compressional is when the two pieces in that fold just are pushed together. And transformative is when you move one to the left and one to the right. Well, they don't go up and down, but they move like a shear. The stress and the strain of this energy release will create some kind of ruptures in those rocks, depending on the elasticity of them, and that will be an earthquake. This energy is transmitted to the surface of the earth and will create heat, create sound. The amount of energy that is released is the strength of that earthquake. The most energy, the stronger will be the earthquake. Well, what is this idea of the fault? Well, the fault is like a large crack in the earth. Well, we need to imagine that our earth is like a round element. Imagine that it's like a big orange, and we have cracks in the surface of that material. Obviously, if we try to release the energy that is inside of the earth, that energy will tend to go out of the cracks. It's similar like we cut with a knife the surface of an orange, and the liquid, the juice of the orange will tend to go out in that crack. It will not try to go out in other place, but in the crack where the surface obviously have some separation. Well, that particular fault have several parts, and those are like fault plane, hanging wall, footwall. Let's look how that works. The fault is the large crack in the earth crust, and we will have like some separation there. We'll have an area that is up and another area that is down when we create that separation. And that will produce the different parts of the fault. I think that it will be easier to look in these drawings. For example, we have in the surface of the earth, we have a fault. The fault divides that surface into parts. In this particular case, starting in the left, we have a part that is gray and another one that is white. Well, the fault is the separation between them. This fault is called a normal one. What normal one? Because we have two walls, like two elements. One is in gray. Let me go back. One is in gray, and that particular area is the one that will, I'm sorry, I'll go next. Okay, one is in gray in the left side, and one is white in the right side. Well, usually the fault is not vertical, it's like inclined. It's like a cut in the earth that is inclined. And we have two particular walls, one that is hanging from the other. Well, we can look here that the gray fault is supporting the white one. Well, the white one is like hanging from the gray. A normal fault will be when the hanging wall, the white one, just drop down. That is because there is some kind of tension, a separation between the elements, what is the normal way. But sometimes there is a reverse force. Well, there is compression. Well, a hanging wall will move up because it's like push. And well, the arrows will show us how there is a separation here, and here there is a compression. Sometimes the faults between them are not going up and down, but are going sideways. And this is a strike-slip fault. The walls will move sideways, not up and down. And that is like shearing. They are separating like shearing Well, we don't have compression, we don't have tension, we have a side movement from left to right. Well, the seismic reformation is when the earthquake will create a kind of static or dynamic deformation. Static is permanent, a permanent displacement of the ground, and dynamic is like a sound wave. Well, the surface will start to move up and down or sideways, and sometimes they will be able to rebound, and that is what is called an elastic rebound. There are many types of waves, and the main classification is on two types: P wave that are primary and S wave that are secondary. The primary waves are the ones that arrive first. It's like a pressure wave. Well, the particle will move along the wave, and they can travel to solid, liquid, gases, and gases, and they can produce like a push and pull motion. What is going on here? Imagine that you have a surface of water that is very flat, and you put a rock. Well, first, the wave will start to move from the place where the rock is to the outside. But that movement will create a secondary wave, the ones that are returning back. And those are the S wave, secondary. They will shake or shear. There are shake or shear waves. They will go sideways. Well, the rock material will move side to side. They are also dangerous, like the primary wave. And rocks are more resistant to sideways motion, and that is an advantage of this wave. They also travel more slow. The disturbance is up and down, and the duration usually is to the right. Well, how we measure all these waves? We need a seismometer, and this is particular element that has a weight, in this case, like it's a round ball that is hanging from a cable. There is a confiner to eliminate the possibility that the weight will move too much, and there is a spring. Well, that particular weight will have a pen attached, and the pen will be touching a surface where there is a paper, and that paper is moving around. It's like in a rotating drum. Imagine that you are printing a material in a plotter, and the paper is rotating around the round elements of the plotter, and there is a pen that will be able to write while the material, the paper is rotating. Well, what will happen is very simple. This particular weight will move up and down, left to right, freely, because it's like a lamp that is just hanging from a ceiling. If we move the building, the lamp will tend to move because it's hanging from the roof. Well, that pen will start identifying movement. In the first moment, when there is no earthquake, the pen will be almost straight, and we will not be able to imagine that there is a movement. If the earthquake is a little bit small and the noise of the earthquake starts, the pen will move a little bit up and down, creating some kind of curves. But when the big wave arrives, the weight of the seismometer will move, that round element will move up and down very fast and will create those big waves. Later on, we'll start moving again, a little bit less probably with S wave. Finally, we can have also surface wave. The surface is moving because it's changing of the direction. Maybe the earthquake make everything to move to the right side, but after, in order to have some equilibrium, everything will move to the left side. We need to measure the earthquakes to understand what kind of damage they produce, and there are at least 20 different types of measurements. The most important are Mercalli scale, that will just go from a range of 1 to 12, and this will measure the amount of damage. When the damage is very big, the maximum will be 12. And when there is very few damage or no damage, we may not even feel the earthquake. Only the seismometer will record that it can be just an Mercalli scale earthquake of 1 in the scale. The Richter is different. The Richter is about the amount of energy that is released. What is interesting of the Richter is that when you have an earthquake, for example, of type 4, because Richter is from 1 to 10. If you have one that is type 4, and later on you have another one that is type 5, doesn't mean that it's just 20% bigger. The difference between the number is 10 times. Well, if you have an earthquake number 4, the earthquake number 5 in the scale of Richter will be 10 times bigger than the number 4. Finally, there is also a moment magnitude scale. That is the measurement of the quake based on the seismic wave and the movement. It's not about the destruction, it's not about energy, it's about how much is moving. Earthquakes can create a lot of damage. Obviously, the main one is when it's affecting the structure of the building and the building can fall down, but can also affect non-structural elements of the structures that are affected. And earthquakes can destroy completely the areas that are more subject to movement. And something interesting of the earthquakes is that they could produce not only a movement that destroy, but they also can produce fire, because we have pipes, we have gas pipes, we have electricity, and that movement will be a release of energy. Earthquakes also may not completely destroy a structure, but it will affect a structure so much that cannot be used anymore and need to be destroyed. And also earthquakes can produce movements in the surface of the oceans and became so dangerous that it's like a tsunami. That is the name that received